Hey, howdy, Algebra 2. Here we are with your test review for standard C, reducing these radicals. I'm going to get you going here on the left-hand side if you need it today. So we got the square root of 45, c to the 7th, d to the 10th. So 45, thinking of a perfect square that goes into there, we have 9 and 5. 9 being the perfect square. Okay, c to the 7th. Remember, when we have variables to an exponent, you're dividing those exponents by the root. So a square root is really a little 2 right there. So 7 divided by 2 is not going to work out perfect. Let's split that up to a 6 and a 1. D to the 10th is a-okay. So now we're going to go through and do the ones that we can do. Square root of 9 is 3. And if you do it, it's on the outside. If you can't do it, it stays inside the radical. We cannot do square root of 5. C to the 6th. 6 divided by 2 is going to be c to the 3rd. C to the 1st stays in. Square root of d to the 10th is going to be d to the 5th. And there we are. 3, c to the 3rd, d to the 5th, with a leftover radical 5c. Okay, same thing for number 3, but it's a cube root. So we got to think of some cubes. We got 8, 27, and 64 to think about there. Zoom out for you. Okay. So 56 divided by 8 would work. So we're going to have 8 times 7. C to the 8th divided by 3, not perfect. Let's go C6 and C to the 2nd. D to the 9th does work out. We can leave that one alone. And E to the 10th, we're going to go 9 and 1. So now we should have numbers that are divisible by 3 for all of our exponents, and we'll have a couple left over. We can do a cube root there, and we'll have a leftover number. Okay, so the cube root of 8 is 2 on the outside, and we'll have a leftover 7 on the inside. C to the 6th. 6 divided by 3, we're going to have c to the 2nd on the outside, and a c to the 2nd still on the inside. D to the 3rd, and e to the 3rd, and e to the 1st on the inside. Onward. 4th root. Oh man. Let's see, 2 to the 4th, 2, 4. 8, 16. 3 to the 4th, 3, 9, 27, 81. So probably going to be using 16. Bingo. 16 is good to go. C to the 8th, 8 divided by 4, that'll work. D to the 9th, 9 is not going to be divisible by 4. Let's split it up. D to the 8th and D to the 1st. E to the 10th, we'll split that up, E8, E2. Alright, 4th root of 16 works out to be a perfect 2. 4th root of c to the 8th is a perfect c squared and d squared. Now we have some leftovers. A d to the 1st on the inside. 8 divided by 4, we'll have e squared out there, and then we'll also have e squared in there. Alright, power parentheses. So remember, our little trick here is to put a 1 on that number, and then we multiply exponents. So this is going to be 27 to the 2/3, and then x to the 2/3 times 1/4. When we're multiplying fractions, it's top number times top number, bottom number times bottom number. So we'll have 2 over 12. Okay, 2 over 12 is going to reduce to 1/6. Okay, now when we're looking at these fraction powers on a number, I like to do the bottom one first, because top's the power, bottom is the root. And so when we go 27 to the 3rd root, that's going to drop it down to 3. And now we still have the 2 on the top, the squared part. So we'll have 9x to the 1/6. Okay, let's reduce the inside on this one. So we got 27 over x on the bottom. We got y squared on the bottom. Z to the 3rd on the top. Okay, we don't want to have any leftovers. So we need 2 more x's and 1 more y on the bottom. So we have to do it to the top and the bottom. X squared y to the 1st. X squared y to the 1st. And now we're doing the cube root of 27 z to the 3rd x squared y over x cubed y cubed. So we're going to have on the bottom regular x, regular y. On the top, cube root of 27 is 3, cube root of z cubed is z, and then we have a leftover x squared and a y. So we want to fix this, we want to reduce inside, then fix the bottom so that it has perfect matching numbers here. And if it was already bigger than a 3, then maybe we go to like a 6. But we want this to be perfectly divisible so we don't have any roots left over on the bottom. Two more to go. Simplifying some roots. Okay, we're going to break these down, and hopefully there's some roots that are similar at the end that we can combine. So we're going to go 8 into square root of 4 is square root of 2. 27 is going to be 9 and 3. 50 is going to be 25 and 2. And 48 is 16 and 3. So now we're going to go through and do the square roots that we can. We got 2 times the square root of 2. 3 square root of 3. 5 radical 2. Minus 3 times 4 times the square root of 3. Now we're going to go back and clean up the ones that have like multiplication in the front. So that's 4 radical 2 minus 12 radical 3. And now let's look to see if we have anything we can group up. 4 radical 2 and 5 radical 2, that's 9 radical 2's. 3 radical 3 minus 12 radical 3's mean minus 9 radical 3's. Alright, last one for us today. We have 3 plus radical 5 over 7 minus radical 5. Remember the trick for us with this, same numbers as the bottom, opposite sign. It's the conjugate. So we're going to go times 7 plus radical 5, 7 plus radical 5. Okay, the top's going to be a little messy. That's okay. We got 21 plus 3 radical 5 plus 7 radical 5. And I'm going to go slow. Radical 5, that's square root of 25. Across the bottom, We got 7 times 7 for 49. This is why we do the opposite sign. Check this out. 7 plus radical 5, plus 7 radical 5, minus 7 radical 5. So those are going to cancel, and a minus radical 25. Okay, this happened on the quiz. And we canceled out down here, and then people tried to cancel here. We cannot cancel plus and minuses on opposite signs of the division bar. If this was all multiplication, we could cancel up and down. But once we start having pluses and minuses, you cannot cancel up and down. You cannot cancel up and down. Okay? So we're just going to reduce. We're going to have 21. We can put these together. Plus 10 radical 5 plus 5 on the top. The bottom, we're going to have 49 minus 5. Okay, put these together. We got 26 plus 10 radical 5 over 44. 26, 10, 44. These are all divisible by 2. Okay. And we'll have 13 plus 5 radical 5 over 22. All right, folks. There it is. A quick little, that's a little bit longer than I thought it was going to be, but we're at about 12 minutes. Hopefully that helped. You guys got the other side to do on your own. Good luck on your test.